The difference quotient is the instantaneous rate of change of a function or the slope of the tangent line. What am I missing here? The difference quotient is?
Almost.
Thank you very much. Very good. Awesome. It's not exactly. You will see when it is exactly, but right now it's just almost. We don't have all the information. Perfect. Thank you. Is the limit of f of x as x approaches 3 from either side equal or not equal to f of 3?
Equal.
That's why I'm kindly asking you to redo the notes. You're going to learn a lot when you redo the notes. So see here, the limit from either side is 4, but the function value is 6. So as I mentioned, the concept of the limit and the function value are totally different. They may equal, they may be the same, but the concept is totally different. The value may be the same, but the concept they are completely different. They're not the same. The concept of the limit and the function value have nothing to do with each other. Nothing. It happens that sometimes they are the same value, but not the same concept. So maybe I shouldn't use the word equal. Maybe that's what it's confusing. Is the limit the same concept? I'm just going to replace this because maybe that's what confused you. The same concept or not to f of 3.
Not the same.
Exactly.
Not the same.
Yes. So I should have said concept because it's much broader and clearer. My fault. So I'm just going to get rid of this. So there is no confusion whatsoever. Because that was slightly confusing. I have to agree with you. Thank you. So next, limit as x approaches a is it finds the of a function when x approaches a. The limit as x approaches a is an what? It finds the of a function when x approaches a. How do we call it? Anyone?
It finds the limit of a function.
So first of all, this is called an operator. So please understand it's called an operator. It does something to a function. Okay, what does it do? What does it find? It finds not the limit. I know what you mean, but we want to explain.
Tendency.
Yes, or the trend. Exactly, that's what it is. It finds the trend of a function, where the function is going when x approaches a from either side. Awesome. Great job. Thank you. So let's continue. Do we have any questions for me? Anything? Any questions?
I had a question about the homework thing.
Yes.
It was the last problem. It was just the way the graph was, where it had the small lines going horizontally.
Yes. Will you tell me which section is that? I'm assuming, or page number. Do you know the page number? That would be
It
great.
was problem 86.
Okay,
And,
86 and
I think it was. Let me check it real quick.
I can find it because I wrote down the pages. I wrote down the page numbers. So this was in 1.1, correct? Okay,
Yeah.
so it's 112. Okay, perfect. '86, you said. Okay, so what was the question about 86?
Oh, it was just finding the limits, but I was a little curious how to do it on that type of graph because
Yes, we had an example like that in class, so let's do it again. Okay, so I chose 82 in class. So then I assigned 86. So you have to look and find where 3.4 is. So 3.4 is here. Since the limit from the left and the limit from the right are the same, your answer is 1.63.
okay.
Now, if the iffy part is, for example, at 2, I think that's why we looked at it last time. The limit from the left of 2 is 1.21, and the limit from the right of 2 is 1.42. That's why the limit from either side is D and E. But this one is right in the middle. The limit from the left is 1.63. The limit from the right is 1.63. Therefore, the limit from either side is 1.63. Is that better?
Gotcha. Yeah.
Awesome. Awesome. Other questions for me? Anyone? Other questions for me? Oops.
I had a question about number 82.
Yes?
I just wanted to see you go over it.
It's exactly the same like what I just said with number 2 for x equals 2. It's the same thing. The limit from the left is 1 and the limit from the right is 1.21. So therefore, the limit from either side does not exist.
I meant I didn't mean this 82. I meant the 82 on page 61. You see this one because I wasn't sure if my math were right. I wanted to see you go over it one more time.
Right. So it will be also presented in the written homework solutions, but let's do that. So we have P equals Q minus 4 everything squared. You know that solutions will be posted, right? You know where they are.
Right.
Okay, perfect. Okay, so we have to set them equal to each other. So when you square this, you get Q squared minus 2 times the first times the second plus the second term squared. And you have to equal it to Q squared plus 2Q plus 6. You simplify the Q squared. You move 2Q here and you move 16 here. So you have negative 10Q equals negative 10. So Q is 1. Now you plug it in. 1 minus 4 is negative 3. Negative 3 squared is 9. So the equilibrium point is 1 comma 3. 1 comma 9, of course. Anything else? Do we have anything else? Other questions? Anyone? Okay. So then let me know if you find anything else. We go back to 112. That was 1.2. Sorry, I really meant to go back to 124. Sorry. Okay. So in 124, on page 124, we started, I just gave you 2 examples. So those examples at the end of last class, use the theorem of limits of rational functions. We already discussed that for a rational function and for the polynomials. So from 9 through 18, I would like us to choose any problem and determine this limit. You can freely choose if you'd like.
Can we go over number 18?
Yes, number 18. In number 18, this is a rational function. So we have the limit as x approaches 3 from x squared minus 25 over x squared minus 5. Good. Every time we're asked to find a limit, we have to plug it in. There are some situations in which we cannot before we simplify a little bit. But in this particular case, we will have to plug it in. So let's plug in 3 at the top and tell me what you get. So let's square 3 minus 25 and tell me what you get. Anyone, please? Anyone?
16.
Negative 16.
Yes, so 9 minus 25 is negative 16. Perfect. And put it on top of the equal symbol. Can anyone plug it in for this one?
4.
Yes. So there is no problem. So the answer, we are applying the limit operator disappears, and we have negative 16 over 4 or negative 4. And this is it. And this happened because 3 was or was not in the domain of this function. Is 3 in the domain of this function or not?
No.
Then I cannot plug it in. If it's not in the domain, then I cannot plug it in. I'm not allowed to. I can plug it in only if it's in the domain. And it's not in the domain if it makes the denominator 0. But I never got a 0 here. When I plugged in 3, I did not get a 0. So therefore, 3 must be in the domain of this function, because it does not make the denominator 0. So 3 is in the domain. That's why I'm allowed to plug it in. Very good. So please keep that in mind. Back to the book. Okay, so how would you calculate, for example, 13? Just explain. How would you calculate the limit for 13?
Plug in 3 for x.
That's it. So for number 13, the limit as x approaches 3. Is 3 in the domain of this function?
No.
You should say, of course it is, because it's a polynomial, and polynomials don't have any problems. Everything is in the domain of a polynomial. X squared minus 4x plus 7 is a polynomial. Therefore, the domain is all real numbers. I can plug in anything I can dream of. So again, as explained last time, it's okay. We need time to digest this. This doesn't happen in one day. I'm not making a point. I'm just repeating because we need to repeat. When we deal with a polynomial, whatever number I have here, it will always be in the domain, because the domain of polynomials is everything. So we plug it in. We have to be careful with rational functions, because if I have here negative 3, it's a different story. And this is a discussion that we have to have soon. Good. So can anyone give us the answer quickly?
4.
16 minus 12, it is indeed 4. Awesome. That's it. And you see the limit operator disappeared. Good. Okay, so we have here a situation called 0 over 0. So I'll come back to it in a second. So two situations are require attention. One is the one that is 0 over 0. So when I plug in other words, imagine that when I plug in 3 here, I get 0, and when I plug in 3 here, I get 0. That will be the situation 0 over 0. This situation has hope. The limit may exist. May exist. The limit. I'm not saying that it's guaranteed. No, I'm only saying there is hope. Because for the second option, which is any number not 0, because 0 over 0 is already a case by itself, this has no hope. Any number divided by 0 has no hope. And what are the options? There are 3 options for no hope. Negative infinity, infinity, or DNE. Here, the answer may still be one of these. But this has potential. This one is dead in the water. Like a fish on the table. This is not going to happen. Never. This one has hope, no guarantee. So let's analyze situations like this and then situations like this. Okay, back to the book. They're already telling us that maybe we get something like that. So allow me to start the first one. Let's say 21, and then you can choose. In 21, we have limit as x approaches 1. Please stop me if you have questions. From x squared plus 5x minus 6 over x squared minus 1. Okay. We always have to plug it in to see the situation. Can you plug in 1? Can you plug in 1 and give me what the intermediate result? What is the intermediate result? This is not the final answer, but the intermediate situation. Can anyone tell us what are these numbers?
Zero over 0.
Okay, so 6 minus 6, 1 minus 1. Okay, so it's this situation. At this point in time, we're going to try this problem, this specific problem, try to factor. Okay, please copy the limit operator. We did not apply it yet. Can anyone factor this for me, for us, and this one? Anyone, please?
X plus 6, x minus 1.
Excellent. And the denominator?
X plus 1.
X minus 1.
See what the problem is here? Imagine that you put negative, move 1 to the other side. This is the problem. But here's what happens. Look at this. I'm eliminating the problem. This is the problem. This is what it creates, 0 over 0. So then I have the limit as x approaches 1 from x plus 6 over x plus 1. If 1 is in the domain, you will apply the limit and give me the final answer. So what is the final answer? And if is 1 in the domain? If it is in the domain, we can get the answer. If it's not in the domain, we have to work on it.
7 over 2.
That's it. The limit is 7 over 2. Thank you so much. And that's exactly when the limit operator was applied. That's why it's gone. And this is the final answer. 1 plus 6, 1 plus 1. Awesome. So not all situations 0 over 0 are as lucky as this one. Good. Okay. Do you want to try anything else here? We could try this one, for example, 27, because it's very different.